Welcome to the Mathematics MI channel. In this video, we are going to solve this interesting integral with golden ratio and continued fraction. Okay, how to begin? Well, first, we all know we can take this part is equal to t. So we can write t is equal to here golden ratio over e to the x plus again we know this continued fraction also equal to t. So here t. Now we can simplify here t times t square plus t times e to the x. Here golden ratio we can write this side minus 5 is equal to 0. Now we have a quadratic equation, so we can write the roots. T is equal to minus b, so minus e to the x plus, so minus square root of b square, we know e to the 2 times x minus again here minus, so plus 4 times golden ratio over 2. Okay, then if we take our integral is equal to I, now we can represent I is equal to integral form. Now here 5 to the x, so here 5 to the x, then here we have minus e to the x over 2 plus, so minus 1 over 2 square root of e to the 2x plus 4 times golden ratio, and here we should write dx. Okay, then here we can integrate this is like a to the x, we know a to the x over natural log of a, so here we have 5 to the x over natural log of 5 minus here again 1/2 e to the x plus or minus 1/2 integral of square root of e to the 2x plus 4 times golden ratio dx. Okay, then we can take this integral is equal to j. So now we should evaluate j. J is equal integral of square root of e to the 2 times x plus 4 times golden ratio here sorry dx. Okay, now to remove the square root sign, we can take a substitution. So we can take e to the x is equal to 2 times square root of golden ratio times tan of theta. Now we should differentiate, so e to the x dx is equal to 2 times square root of golden ratio times derivative of tan, we know secant square of theta d theta. Now we can isolate the dx, so dx is equal to 2 times square root of golden ratio here secant square of theta d theta over here e to the x we know 2 times square root of golden ratio times tan of theta. Now we know this 2 get cancelled, golden ratio get cancelled, and we will have secant square of theta over tan of theta. Now we can plug in here. Here we have now square root of now e to the 2x. E to the 2x we can take square in both sides, so here 4 times golden ratio times tan square of theta plus 4 times golden ratio, and dx we know secant square of theta d theta over tan of theta. Okay, now we can simplify here. We can take 4 times golden ratio so as a factor, so here we have 2 times the square root of golden ratio times square root of 1 plus tan square of theta, we know secant square of theta, square root of secant square of theta, we know secant of theta, and here we have secant square of theta over tan of theta. Tan of theta we can write sine of theta over cosine of theta d theta. Okay, then we know secant of theta, cosine of theta get cancelled, and 2 times square root of golden ratio is a constant, so we can write outside of the integral sign. Now instead of secant square of theta, we can write tan square of theta plus 1 over sine of theta d theta. Now we can write 2 times square root of 5 times, now here tan square of theta over sine of theta. We can write tan of theta is equal to sine of theta or cosine of theta. Sine of theta get cancelled, so we will have here tan of theta secant of theta, here integral sine d theta plus 1 over sine, we know cosecant of theta d theta. Okay, then now we can integrate 2 times square root of 5. Now we know the derivative of secant of theta is equal to tan of theta secant of theta. So here we have secant of theta plus, now integral of cosecant of theta, we know we have minus, so here this is minus natural log of cosecant of theta plus cotangent of theta plus c. Okay, then here theta we know our substitution, so we can isolate the tan of theta. We know tan of theta is equal to e to the x over 2 times the square root of golden ratio, and now we can isolate the theta. So theta is equal to arctan of e to the x over 2 times the square root of golden ratio. Okay, now we know this is the answer, and here theta is equal to arctan of e to the x over 2 times the square root of golden ratio. Okay, thank you for watching.